Hello, welcome back to BlenderSushi Live Noding. In this video, I'm going to explore further the idea of creating armature and bones procedurally and also animating the bones. We're gonna look at probably creating like a flower kind of growing or kind of opening up. In the past, we have learned how to kind of create like the petals of flowers and kind of animating the scale only. But now I'm thinking like maybe we can use joints to do the same thing. And if I draw it using grease pencil, maybe I'll switch to the top view. This is it's gonna be the plan. Um, this is the center part of the flower. The petal is what we're gonna be animating. Obviously, it should have like we should have control over the number of petal, but that's another different problem. The petal itself can have different shapes. We're gonna just keep it simple. What we're gonna worry is more the bones itself. Imagine this is like an armature, and we kind of drawing the armature. Maybe I should use different color for that bones. Create new color, and let's pick a red color. Imagine that's the bone. We can approach this in many different ways. A simpler version if we use like a Blender B Bones. Probably B Bones is good, but it's B Bones cannot curl. If we use Blender, sorry, Blender Bendy Bones. Bendy Bones can have multiple segments, and multiple segments with a simple control. That's probably gonna be for the next video, but for now we're gonna use like a multiple bones, like a normal multiple joints like that, and we're gonna make it so the bone is arranged like a star shape, kind of like a flower shape, and then we're gonna try to control the rotation using animation nodes. I'm gonna set up the bones and draw the bones using Sverchok just for simplicity. I think that's the workflow I like to use at the moment. So let's create new blank Blender files, delete the default cube, hide the lamp and the camera. File, save as. This is gonna be animation nodes and Sverchok flower opening up. Flower animation, I guess. So let's start with a Sverchok. Let's have a think on how we can create like a kind of like a star pattern. Let's start with a line. The line is gonna be our joints. We don't know how many points the joint's gonna have, like how many segments, but we can think about that later. So imagine this is like an armature joints, and we have 4 segments. We can have more or less. That's something that we're gonna think later. This is just for a single flower petal, so let's create a multiple petal. Just like last time, we're gonna use circle. Circle is always an interesting problem. Also interesting solutions. I guess that's how I like to think of it. Currently, you look at this. Okay, it looks like pretty complicated. Let's reduce the number of vertices for now. So this is basically the line, but being arranged in a circular kind of pattern. Because of this circle, we can have less or more. If we have less, we can see more clearly. So that's the line being placed around the circle. So this can be our starting points. But of course, currently the line is kind of going in that direction. That's the default line kind of direction in the x-axis. That can be for our advantage actually. If we want to make this line becoming more like this, like a ray in that direction. We can simply use the rotation here and the angle. I learned this technique from example by Nikita, Sverchok developer. Basically, we provide rotation angle, which is the rotation angle can be the z. So if we give it like a vector z in the rotations, we can have control over the angle. Let's have a look real quick. See the angle now kind of moving like in a counterclockwise if we increase the number. So that's gonna be the plan. So using the advantage of a line being drawn in the x-axis, we can rotate each and every line kind of slightly until it makes like a 360. So in order to do that, for the angle, we really need to use a float range. It's funny how range integer range float. Okay, we can use the count and step. Actually, we can use either of these. If we are using start and stop and plug into the angle, you can see that we need to match it with the number of vertices here. So I'm gonna use integer input, plug into that guy. So now currently we can't see clearly what's happening, but if I give like 360 to the value here, you can see that it's starting to kind of giving what we need, although there's something not quite right there with the count. Maybe the count needs to be add 1 or -1. +1, integer +1, plug into the count. It's refusing to do anything. Okay, need to update it. X -1 probably is more correct. No, it's apparently not doing what we need to do. Instead of using counts, let's use step, and then let's see, step. The step should be the number of should be the angle. So let's say let's have like 10 points for simplicity, and then the step should be, in order to make 360 degrees, the step should be like 36. Yeah, I think that's correct, but it's not giving the result. $36. If we change it to this guy, I guess that's correct now. 36. Yeah, okay. In order to get the number, then we need to use another math. So this is gonna be maybe multiply like division, and 360 divided by 10, we get 36. Plug into the step. Okay, let's check it out. Alright, now we get what we want. So it's like this is exactly what I'm trying to do. File, save as, save it again. Okay, anyway, let's delete the grease pencil. So we have starting point here. we can have more or less joints for the petal. Let's have like 5 for now. I don't know what's gonna happen. I haven't actually tested it out before I make this live noding video. Let's start with 8 petals. So it's for simplicity, 8 petals should be good. So this is gonna be our joints. Let's generate like a mesh from this guy. I'm gonna use bmesh mk2 viewer, vertices and edges and the matrix, and then merge it. So now we have this single objects generated using Sverchok, and I'm gonna turn this into skin modifier. Skin modifier, and then actually gonna turn off this guy. I just gonna delete it for now. We have what we need. Switch to edit mode and mark the root. Okay, so we have like a mesh to work with. Something about skin modifier that's interesting is if we go to the edit mode, and if we're really modifying the weighting underneath, if I use Control A, we can actually control the kind of like the size of the skin, kind of. And what's interesting is that we can also control it in the just a single axis kind of way. So Control A and Z. Let me try again. Control A and the Y. So I can kind of squeeze that skin modifier. And in fact, if you want to make this a little bit nicer, we can actually script this using Sverchok, you know. This is just to make the petals slightly more like flower. Yeah, I guess that's should be okay for what we are doing. Maybe Control A and Y and make it thinner. Okay, let's switch back to object mode. Save this real quick, so in case it crashes. Okay, now it's pretty good. What do we have now? Like I said, with the skin modifier, we can create armature very easily. Just click on the button, and we have armature. And the plan is, of course, to go inside the pose mode here, and then kind of rotating the bone in such a way that it's kind of like a flower curling in and out. Yeah, let's try. Okay, that's the twist. That's the X. Normally, I don't know how the animator does it. I don't know how. Maybe they have a way to do it, but I think they can switch to the individual origin and then select all these and then kind of animating it all at the same time. I don't know how the animators do it. Maybe they use driver and the rigger kind of setting up for each bone. If they wanna rotate all the bones at the same time. In a software like Maya, you select this guy and then you can kind of rotate all at the same time. Not in Blender. I think I need a way to kind of figure that out. But today I'm going to use animation nodes to do that. So switch to animation nodes, and we're gonna do just like before. We're gonna load the script that's gonna control all of each bones. So I'll open the script, get it. Animation nodes get post bone. So that's the script we are using. If you don't know what this script does, look at the previous live noding video. So this is the armature. I'm gonna grab it using this node, which is a script node. Create a script node first, grab the script, and then create a node. This says get post bones. Name armature is not defined. It's actually, it should be like object. I'm gonna rename this, and then the output's gonna be the bone list, and the bone list is also object list. So this is gonna be bone list. It's actually post bone. Okay, now we have what we need. The non type have no attribute post. Actually, I shouldn't change the name of this. Okay, get the armature. Now the node is not complaining anymore. Switch to animation nodes. Turn off always. Turn on this guy, so it's a little bit faster. Now what I want to demonstrate is just to make these flowers kind of curling in and out. Currently it's just flat. I don't know, maybe we should edit the flower so it looks more like more natural. Editing the bones, we can do it using, I don't know, I think we can use Python. If we can use Python script to kind of reshape the bones in edit mode, then we can use animation nodes. I haven't looked at that properly. For now, let's just use the post bone and animate the bones procedurally. So the rotation is quaternion, and we cannot use object transform output. I'm just gonna grab this guy. I switch to post mode first. Grab the rotations attribute, copy data path, and object transform object attribute output. Paste it there. This is we only need the rotation quaternion. Plug in the object there, and value has wrong type. That's a good sign. We just need quaternion input. This is just for a test. Let's have a look. I think this should actually work. Okay, that's working. Okay, perfect. That's exactly my plan. Let me save this first. So obviously the value from -1 kind of curling that way, and then 1 will curl it up like that. It's currently not exactly like flower, but it's a start. Maybe the flower. Maybe we can use like quaternion math. I have never used quaternion math, but let's see if this is actually working. So of course the Z and the Y give kind of a curling. That can be useful. This seems to be adding on top of what we have, so that's a good, kind of nice. So we can have that kind of result. Yeah, that's pretty cool. That's pretty much what I want to show you, except that maybe we can do a little bit more with Blender Bones. If I switch to edit mode, currently they are all kind of connected. I wonder if I can separate them, or if I switch to the post mode. I wonder if I can just disconnect them. Back to edit mode, and if I clear parent, for all of this bone, clear parent. Switching to post mode now. Now we can actually control each and every bone separately. I don't know if this is a good or a bad thing. Maybe this a nicer way is to have like a kind of hierarchy, so the bone can kind of curl, but the bone can also kind of separately disconnected like this. Animator always like that kind of control if needed, otherwise it's just gonna complicate things. Currently the rotation is now separate, so that's probably, it's gonna be weird, but I want to show you something that maybe maybe we could actually kind of play with this a little bit more with a bone position, for example. I have not tested this. It's funny that the flower currently kind of like a Rafflesia flower. It's kind of like a flower that you can find in Indonesia. It's like a giant flower. And it's really smelly, and that's kind of how it looks at the moment. Anyway, if we're rotating it, because we don't have the parent and child relationship anymore, so it's kind of broken. We cannot really curl the flower anymore unless I'm using like a special math here, and I kind of have the effects set accumulative for each and every bone's position. No, I'm not gonna do that. I'm gonna try using object transform output, and let's see what we can do with this. The Z, that's the X, okay. So the X is offsetting in the X. Obviously, you can also do something with the scaling. I turn on scaling, turn off that guy. Scaling, controlling the scale. But as a bones, it's not scaling the flower. Interesting is it's kind of becoming like a modeling tool as well, like a unusual kind of modeling technique, but maybe you can think of something that uses this. The weighting, this is quaternion, so it has a weighting. Very interesting. I'm gonna save this, save it again. So flower, kind of wondering if we use like a sine on the Z axis. Let's use math and sine and a frame. The sine will give like a wavy kind of motion. Plug it into the Z. Let me check what's doing at the moment. So it's doing that. It's pretty cute, but not so interesting. It's doing it in the Z. Okay, that's all right, but with the sine, it's always nicer if we can stagger the effects. To stagger the effects, we can use delay time, and delay can be plugged into the index. So now we have like a wavy flower. Kind of what I like to do, but I kind of want to do it on each and every flower, but each one has the same kind of motions. But because we have like a single armature only, and then each flower petal have like this chain joints they are all in one list, so they're looking funky at the moment. There must be a way using math here, so we can kind of separate each bones. You know what I mean? So currently we have multiple bone chains, and then supposedly I want to make its flower kind of waving in the same kind of way. Currently it's a little bit funky like that. Let's see if I could think of something. Okay, maybe modulus. The modulus might be our key to do this. If you use the modulo, okay, modulo. And how many bones we have? 1, 2, 3, 4, 5. 5 bones. Modulo 5. Or we can use like a repeat time. No. Maybe not repeat time. Maybe modulo plug into the delay. Modulo 6. 4. There we go. That's kind of the motion I'm trying to do. The funny thing is, it's kind of looking like a jellyfish kind of motion. I didn't expect this, but it's maybe this is also something we can use. Let's rotate the jellyfish a little bit. I mean the flower. It's very interesting looking wave. It's a little bit fast at the moment. Let's slow down the time. Use math. And multiply smaller value. So this is a little bit slower. Sine is cool, but sine also a little bit boring. If there is other function here that we can kind of mix to get the motion right, we can have a better kind of effect. Of course, animation nodes have all kind of F curve that we can use. Where is it? Interpolation. Construct interpolations. Let's think like this. Elastic, bounce back. All this can be useful to kind of reshape the sine motion. The sine motion, because the sine motion is if you want to know the math, if you don't know the math, the sine motion is basically like a wave going from let me stop the playback. If this is like a 0 value, sine wave is kind of doing that. This is top value, this is -1 value. Currently what's happening is our joints, each and every joints is doing the wave kind of motion. I can play with the amplitude and the number of frequency and amplitude here if we use more math. Put it there to more. So that's kind of the effects we get. The funny thing, if we have like a lot of more joints, this can be more interesting, of course. A little bit more like jellyfish. I don't know. Jellyfish actually is something that I was thinking to do. Jellyfish is definitely one of the creature of nature that it has kind of like a tentacle like this, and the motion of jellyfish is beautiful. It's like there is a math behind it if you want kind of thinking about jellyfish and the way it moves in the ocean. So jellyfish, and then what else? Octopus, maybe with the tentacles. Kind of something I want to do next. This flower is kind of pretty much done. as long as it can curl, I'm pretty happy with that. Although the curling, maybe in the next video I'm gonna kind of do the flower again, but using B bones. So B bone. What cool about B bone is, of course, B bone cannot curl, but B bone can easily make shapes like S shapes and a C curve like that. So B bone is really handy for flower, and B bones can control the segment even after you skin it and so on. That's a B bone is gonna be next, I think. With curling, currently the curl is too simple. The curl is only doing that, kind of something you see in the flower. But in another video, maybe I want to try curl that's more like a rolling, like a paper towel kind of rolling. This needs kind of math that I don't know yet if this is possible. This is the curl that you might see in a creature like the chameleon. So or curl that you might see in the butterfly as well. So that's there's also kind of like procedural animations problem that I want to solve using animation nodes and Sverchok. So there you go. This is kind of the flower. Bless you. Kind of flower kind of problem. It's basics, but maybe it's something that you can start with and can make it better. Okay, but this is kind of the basic. Okay, thanks again for watching this video. Please leave comments and suggestions down below. If you like the video, please also give a thumb. If you haven't subscribed already, you can subscribe to the channel so I can continue making video like this and kind of dissecting animation procedurally. It's kind of my interest, even though it's still basics, but I think it's gonna be useful for everyone after some points. The reason being is because Blender is open source, and then currently we have really nice tools like animation nodes and Sverchok. I don't know if they are continuously being developed or not, but over time, you know, tools like this, while it's available, you can use it to do like a teaching and learning, and you know, just to get you further, whether you're like a starter beginning to learn about scripting or Python programming and math and all that. If you're using Node, you kind of can make that more physical in a way. You can have a look at the result, and you're doing it all in a 3D software like Blender. And really, this like I really want to thank all the developer working on Blender, and then and also for the add-on like animation nodes and Sverchok. Those two really helps me, I think, personally, and hopefully can be helpful for everyone as well. Yeah, anyway, that's flower curling procedural animations deconstructed using Sverchok and animation nodes in Blender. Okay, thanks again. I'll see you in the next video.